You're welcome to my Calculate Math YouTube channel, where I'm devoted in building students to zero tolerance for the fear of mathematics. There is a popular saying which says, we would only be remembered by what we have done. As a student of mathematics, one of the subjects most of us find challenging is reanalysis, due to so many reasons. To solve this problem, I took it as a challenge to attempt all the problems in one of the best reanalysis textbooks written by an African mathematician, Charles Chidume, who was born in the year 1947 and died on 7th of October 2021. May his gentle soul rest in peace. In this video, I'm going to be providing a solution to the first chapter, that is the real number system. I will leave the link of the questions in the description box below. Before we begin, I want you to click on the subscribe button. Of course, it is free. And also on the notification bell so that you'll be notified whenever I upload a new video in this series. Without loss of generality, let's head over to our video for today. In this question, they said prove that if epsilon is greater than 0 and a, x belong to a set of real numbers, then the absolute value of a minus x is less than epsilon if and only if x minus epsilon is strictly less than a, which is also strictly less than x plus epsilon. Now let's try to visualize this problem. Now, since I picked two real numbers, two things are involved, or three things are involved. It's either x is greater than a, or x is less than a, or I have x to be equals to a. Okay, if you pick two real numbers, either of these three is true. One of these three is true. It's either x is greater than a, or x is less than a, or x is equals to a. For example, if I pick 1 and 1, okay, that means x is equals to a. If I pick 1 and 2, it's either 1 is less than 2, which is true. Okay, now let's try to fix x. Okay, and now they said the distance between a minus x is less than epsilon. What they are trying to say is that, let's say I fix x and I try to move some distance a away from x. Let's say this is a, okay, and I'm careful enough in such a way that the distance between x and a is actually less than what is actually less than epsilon. Okay, so let's say this is to the right of this is x plus, let's say this, the point here is x plus epsilon. Okay, now let's try to break it down further. Now let's say I have a circle with center x and radius r. Here the radius here is like epsilon. Okay, now I'm trying to say that the point a would be inside the circle, okay, in such a way that if I should take the distance between x minus any point, the point a inside the circle, okay, it has to be less than epsilon. It has to be less than epsilon because the point a is actually inside the circle. Okay, so which actually really makes sense. Okay, now even if I try to move to the left of a, let's say a is somewhere here, okay, don't forget that I have to be careful in such a way that if I should take you can think of epsilon as radius. Okay, if I should go to the left direction, which is the point here will be x minus epsilon, okay, you will see that point a still falls in the neighborhood of x. Okay, now let's say x is now a. If x is obviously a, you would see that if this is x plus epsilon and if this is x minus epsilon, you will see that a will still fall inside this interval. It will still fall in the interval of x minus epsilon comma x plus epsilon. You can see it here. Do you get it? Now you can see that if I pick two real numbers such that distance between that real numbers is less than an epsilon I picked, okay, this will always be true. In fact, if this is true, then this is also true. If this is true, then this is also what's true. So this is a biconditional statement, and that's what we want to prove in this video. And one thing about biconditional statements is that you would assume that for you to prove a biconditional statement, that's if and only if. Okay, if a is true, then b is true. If b is true, then a is what? It's also what? It's also going to be true. That's a biconditional statement. And for me to combine those two statements, I will just say that A if and only if what? B. Okay, now let me try to write it out. What I'm saying in essence is that if A implies B and what B implies what? A, definitely A if and only if what? If and only if B. Okay, so another way of writing these two statements is what? If and using the if and only if statement. So what I want to do in this video is that I want to prove that if I pick an epsilon to be greater than 0 and let's say a comma x is in R, okay, if a minus x is less than epsilon, then this is going to be true. Then conversely, all right, conversely, if epsilon is greater than 0 and I pick two real numbers, if this is true, all right, then the first statement is what? Is also true. So that's what I want to prove in this video. So anytime you have if and only if statement, you want to prove the necessary condition, and at the same time you want to prove the sufficient condition. So let's go ahead and prove that statement now from the explanation I made earlier, okay, if I pick two real numbers, okay, two things are actually involved. We can actually break this into two cases. Okay, so let's say let's epsilon be greater than 0 and I pick two real numbers. Okay, so I would assume that this statement is what is true. Assume that the absolute value of a minus x is less than epsilon. Now what did I want to prove? With this statement I want to use these conditions to prove that this is what is also true. So if this is true, then this must be true. Okay, so if epsilon is greater than 0 and a comma x be in R, of course R is our set of real numbers. Okay, so I can break this into two cases. The first case is the fact that if a is greater than x. Okay, so if a is greater than x, now don't forget that the absolute value of x itself, that is the definition of the absolute value of x itself, is what? Is x. If x is greater than 0, then it's 0 if x is equals to 0, and it's what? Negative x, that's if x is less than 0. Okay, now let's come back to this proof here. Now if a is greater than x, what will happen to the absolute value of a minus x? The absolute value of a minus x would, of course, what will be in this place will be positive. That means this is going to be what? A minus x from the definition of absolute value here. Okay, which is what? Which is less than epsilon. Okay, so this is going to be less than epsilon right from here. Now don't forget that what? Our epsilon is greater than 0. Now this one we can still rewrite this as what? We can rewrite this as 0 to be strictly less than a minus x, and which is also less than what? Epsilon. Okay, now if epsilon is greater than 0, definitely if I should multiply this by negative or divide this by negative, I'm going to have negative epsilon is going to be less than 0. Okay, so don't forget that anytime you are dividing by a negative sign, your inequality will be what? Will be reversed. Now if negative epsilon is less than 0 and I also have 0 to be less than a minus x, which is also less than epsilon, so if I should combine these two inequalities together, that means that what I'm going to have what? Negative epsilon to be less than 0, which is less than a minus x, which is less than what? Epsilon. So this implies that what? Minus epsilon is going to be less than a minus x, which is less than what? Epsilon. So if I should add x to both sides, so if I should add x here, I should add plus x here and plus x here. So what am I going to have? That means that I'm going to have what? X minus epsilon to be less than a, which is less than x plus epsilon. Okay, so we have this result here. Okay, that's just for the first case. Now for the second case is when what? A is less than x. Okay, so if a is less than x, from diagram, if a is less than x, what will happen to the absolute value of a minus x? Obviously, if a is less than x, what will be here would be what will be negative. So that means that this is going to be negative. This is going to be negative. A minus x is going to be what? Negative. So meaning that this would give us what? Negative of a minus x from this definition here. Yeah, okay. Since a minus x is, since a is less than x, definitely a minus x is going to be what? Negative. Okay, so that means the absolute value of a minus x is going to be what? Negative of a minus x, the argument, which is a minus x. Okay, definitely this is going to be what? Less than epsilon, just directly from what? Just directly from here. That means that what I can write this as what? If I should swap this, that means I can write this as negative epsilon to be less than what? A minus x. Obviously, if you should have, you have a minus x here and you have negative epsilon here, definitely you must have what? 0 at the front. So that means we have 0 at the front here. Now don't forget that what we have our epsilon to be greater than 0. Since epsilon is greater than 0, definitely 0 is going to be less than epsilon. Okay, if a number is greater than 0, that means 0 is less than the number, obviously. Now if I should combine these two inequalities together, so what am I going to have? That means I'm going to have negative epsilon to be less than a minus x, which is less than 0, which is less than epsilon. Or I can write this as what? Minus epsilon to be less than what? A minus x, which is less than epsilon. Okay, again, if I should add x to both sides, if I should add x to each of these sides, I'm going to have this to be what? X minus epsilon to be less than a minus x. Oh sorry, this should be ordinary a because I've added x, because x minus x will cancel out, then I will have this to be what? X plus epsilon. Now you can see that in both cases I have the same result. Okay, so that means that we are done proving this this necessary condition. So let's try to prove the sufficient condition. So here we say let epsilon be greater than 0 and a and comma x being r. Okay, so we assume that x minus epsilon is less than a, which is less than x plus epsilon. Then we want to prove that the absolute value of a minus x is less than epsilon. To do this, you break it into two cases again. So the first case is when if my a is greater than x. So if a is greater than x, what do you observe? You observe that what? The absolute value of a minus x is going to be what? Is going to be a minus x. Okay, and obviously this inequality here, we can write this inequality here as what? We can write it as negative epsilon is less than a minus x, which is less than what? Epsilon. Okay, now let's come back to this this proof here. So if a is greater than x, the absolute value of a minus x is going to be what? Is going to be a minus x. That's if a is greater than x. And from here, a minus x is what? Is less than epsilon. From here, it follows directly from here. A minus x is less than epsilon. And now we can now conclude that what? This implies that what? The absolute value of a minus x is what? Is less than epsilon. We are done. So for case 2, if a is less than x, what happens to a minus x? A minus x is going to be what? Negative of a minus what? A minus x, which is less than epsilon. Okay, obviously directly from here, this is going to be okay, this is going to be less than epsilon. How do I know? Because if I should write this inequality, I'm going to have what? If I should bring this one to this side, and I also bring this one to this side, okay, I'm going to have negative epsilon to be less than what? A minus x, which is true directly from here. This is true. Okay, so it's just a way of writing it. So that means that what? That means that the absolute value of a minus x is what? Is less than epsilon. It's true for both what? It's true for both cases. So once we are done, once you've considered all the possible cases, these are just the two possible cases. The third case in which we want to consider is if a is equals to x, and if a is equals to x, it's of a trivial case. Okay, if a is equals to x, obviously I'm going to have 0 to be less than epsilon. This is trivial. Obviously epsilon is greater than 0. So these are just the two possible cases we have. So here we can just conclude from here that the proof is what? The proof is complete. The proof is complete. So let's just move ahead to the next question. In this question, it said find all x in R that satisfy the following inequalities. The first inequality here is the absolute value of 4x minus 3 to be less or equals to 11. Now I'm going to solve this problem with two different methods. Now let's start with the first method. Now since I know that my solution will be on the real line, I can decide to partition my real line. Now how do I do that? Now the argument here is 4x minus 3. I can decide to set it to be equals to 0. Now if I should set 4x minus 3 to be equals to 0, that means that what? That means that my x is going to be what? My x is going to be 3 over 4. Now since my solution is on the real line, so let me draw my real line. So I will have two different sections. The first section here is, now this is point 3 over 4. So if I should break this into two sections, that is the section where x is strictly less than 3 over 4, and the section where 3 over 4 is less or equals to x. Okay, of course this is two different sections. Now don't forget that the absolute value of 4x minus 3 can be written as what? Can be written as 4x minus 3. That's if what? If x is greater than 3 over 4. And it's going to give us negative of what? 4x plus 3. That's if x is what? Is less than 3 over 4. Okay, now I'm going to solve this inequality in these two different sections. So for the first case is when my x is strictly less than 3 over 4. For the first case, that's if x is less than 3 over 4. What happens to the absolute value of 4x minus 3? The absolute value of 4x minus 3 becomes negative of 4x plus 3. Okay, which is obviously less or equals to 11. And now if I collect like times, that implies that what? I have minus 4x plus 3 to be less or equals to 11, which implies that minus 4x to be less or equals to 8. And if I should divide both sides by negative 4, I'm going to have this to be what? I'm going to have my x to be greater or equals to negative 2, because I'm dividing my negative sign, so my inequality will be reversed. Therefore the solution set for this case is what? Now let's try to draw the solution set. Now we have two conditions. The first condition is when x, so let's have on our, let's say this is our real line. Now let's say this is our real line. Okay, and here we have this to be negative 2, and here we have this to be 3 over 4. Okay, we are considering the region 3 over 4 when x is less than 3 over 4. So we are looking at this region when x is less than 3 over 4. Okay, and now we now have another case. We have this result. We have x to be greater or equals to negative 2. So when x is greater or equals to negative 2, so that means I will shade this area, then move it to this direction. Now if you should look at the intersection of these two graphs, so what is the intersection of these two graphs? The intersection of these two graphs, okay, which is the solution set for this case, is what? It's just simply what? Negative 2 comma 3 over 4. So it is closed at this end and is open at this what? At this end. Obviously you can see it from this graph. Now let's try to consider the second case. Okay, the case where 3 over 4 is less or equals to x, or we can write it as what? We can write it as when x is greater or equals to 3 over 4. Okay, so when x is when x has passed this stage, okay, so we have this stage. So when x is now in this stage now, so what happens to the absolute value of 4x minus 3? The absolute value of 4x minus 3, in the case where x is greater or equals to 3 over 4, so this is going to give us what? 4x minus 3. Okay, from this side here, from this definition of this absolute value of 4x minus 3 here, which is going to be what? Less or equals to 11. And if I should call it like times, that means I'm going to have 4x minus 3 to be less or equals to 11. As is, if I should add 3 to both sides, I'm going to have 4x to be less or equals to 14. And if I should divide both sides by 4, I'm going to have x to be less or equals to 7 over 2. Okay, so let's try to consider the solution set for this case. Again, we draw our region. So here we have, on our number line, we have 3 over 4 and we have 7 over 2. Here we have x to be greater or equals to 3 over 4, so we have this. So we shade this region, go in this direction, and here again, so this is the direction here, and here we have 7 over 2. X is less or equals to 7 over 2, so we have here in this direction, so we shade this in this direction, so we have this. So what is the intersection of these two graphs? The intersection of these two graphs is what? They intersect at what? At points 3 over 4 comma the interval here is what? 3 over 4 comma 7 over 2, which is what? Closed at both ends, due to the fact that this is closed at this end and this is also closed at this end. So this is their intersection. Okay, so these are the intersections. So the solution set for this case is what? Solution set for this case is what? 3 over 4 comma 7 over 2. Now, since we've considered the two cases, so this is case 1, this is case 2, so what we need to do next here is to now take the union of what? Of the two cases. So if we should take the union of the two cases, taking the union of case 1 and case 2, so what happens? So if I should take the union, so the solution set is going to be like this. So I'm going to have negative 2 comma 3 over 4 open at this end, union closed at this end, that's 3 over 4 comma 7 over 2. So what will this give us? This is going to give us what? Obviously this is going to give us negative 2 comma 7 over 2. Why? Because this is open at this end and why this is closed at this end. That means it's including points 3 over 4 here. Here 3 over 4 is not included. Okay, so but here is included. So if I should take the union of these two sets, I'm going to have what? Negative 2 comma 7 over 2, in which 3 over 4 is going to be part of this what? It's going to be part of this set. Of course, this is the solution set of this what? Of this for this inequality. So let's proceed to the second method, which is actually the fastest method. So you recall that what? Recall that anytime you have the absolute value of a to be less than b, okay, or less or equals to b, so this implies that what? This implies that negative b is less than a, which is less than b. Of course, we've done this in our first exercise. You can just go back to the first exercise and check this theorem. Okay, that's if we should let the other point x to be 0, so we have this this directly, which is true. Okay, so if you should have absolute value of a, the absolute value of a less or equals to b implies that negative b is less than a, less or equals to a, which is also less or equals to what? Less or equals to b. Now in this case, we have the absolute value of 4x minus 3 to be less or equals to 11. So this implies that what? This implies that what? Negative 11 is less than what? 4x minus 3, which is also less or equals to what? 11. Okay, so if I should add 3 to both sides, to each of these term here. That means I'm going to have what? I'm going to have negative 11 plus 3 to be less than or equals to 4x to be less or equals to 11 plus what? 3. And here I'm going to have this to be what? Negative 8 to be less or equals to 4x, which is less or equals to what? 14. And if I should divide all through by 4, okay, so I'm going to have this to be what? Negative 2 to be less or equals to what? X to be less or equals to 7 over what? 2. So I can write this in interval form to be what? Negative 2, 7 over 2. So which is still what? Still the same thing. So let's go ahead to the next question. Okay, we are still on question 2, but let's just move to the second question on question 2. Now for the second question, we are asked to solve this inequality, that is the absolute value of x minus 2 to be greater than the absolute value of x plus 1. Of course, I will also solve this using two different methods, but let's consider the first method. The first method, I think the first method is actually the most classical method, okay, for solving any absolute value problem, and it's done by partitioning the real line. Okay, so now, and how do I partition the real line? I just take the arguments inside this absolute value and set them to be equals to what? 0. Okay, so if I should do that, if I should set x minus 2 to be equals to 0, and I should also set x plus 1 to be equals to 0, I'll find that that's what I find that my x is going to be what? Negative 1 and what? And 2. Okay, so here, let's say I have my real line. Let's say this is my real line here. I have this to be negative 1 and I have this to be what? 2. So I'm going to have three different regions or three different cases. Now the first one is when x is what? Is less than negative 1. The other one is when x is greater or equals to negative 1 but strictly less than 2. And the third region is when 2 is less or equals to x, or when x is greater or equals to 2. Either one is correct. Okay, so that one is that. So the next thing I may want to do now is to now write my definition of the absolute value of x plus 2. Now, what is the definition of absolute value of x minus 2? So this is going to be x minus 2. That's if my x is greater than 2, and this is going to be negative of x plus 2. Okay, that's if x is less than 2. And how do I obtain that? Look at it. It just follows directly from here. That's if x is greater than 0, and negative x, that's if x is less than 0. Okay, so what I did here was that I set x minus 2 to be less than 0. That means x is going to be less than 2. That's why I have this condition. And if x minus 2 is greater than 0, that means that what? X is going to be greater than 2. That's why I have this condition. So if I should let me just rub this off. And now for the second one, if I should have the absolute value of x plus 1, the absolute value of x plus 1 is going to be broken into two forms. That's what? X plus 1, that's if x is greater than negative 1, and negative of x plus 1, that's if x is less than negative 1. Okay, so I think I've done that earlier. I've explained that earlier. So I want to solve this inequality in three different cases. Why am I having three different cases? It's because I had two partitions or two x values on my real line. So I want to consider three different cases. So the first case is when my x is strictly less than negative 1. Okay, so if my x is strictly less than negative 1, what am I going to have? I'm going to have now, if x is less than negative 1, Okay, obviously x is going to be less than 2 also. If x is less than -1, x is going to be less than 2. So here we are going to look at this condition here. We are going to look at the condition here. So this is this is for the first case. So we are looking at x less than -1. Okay, and also we are also looking at x less than 2. Okay, so here we are going to have this to be what will happen to the absolute value of x minus 2 if x is less than 2. So I'm going to have this to be negative of what? I'm going to have this to be negative of x plus 2 right from the definition here, to be greater than, if x is less than -1, I'm going to have this to be what? Negative x negative what? 1. Obviously, if I should bring x to the other side, this is going to cancel out, and I'm going to have 2 to be greater than -1, so which is true. So that means the solution set for this is just, so that means the solution set for this case, so therefore the solution set for this case is just only this. So we can write this as what? Negative infinity comma -1. This is another way of writing this interval. Okay, negative infinity comma -1. Now for the second case, that's for case 2, that's when x is greater than or equals to -1 but strictly less than what? 2. Okay, so let's look at that case, meaning that here we are looking at this region. That's if x is now in this region now. Okay, so if x is in this region, that means x is greater than -1 and it's now less than what? 2. So we are looking at x greater than -1 and now less than what? And now less than 2. Okay, so these are the two conditions we are going to be looking at, this condition and this condition here. So what will happen to absolute value of x minus 2? That's if x is less than 2. It will still remain as what? It will still remain as negative of x plus 2, and here I'm going to have this to be greater than. Now what will happen to the absolute value of x plus 1? The absolute value of x plus 1 here, that's if x is greater than -1, I'm going to have it as what? X plus what? 1. And if I should collect like times, so that means I'm going to have this as what? I'm going to have this as coming. This is if I should collect like times, I'm going to have -2x to be less than or to be greater than -1. And if I should divide by negative sign, let's divide this by negative sign. So that means that I'm going to have this to be, that means x is going to be less than, strictly less than 1/2. Okay, so I have this condition here and I also have this result here. So let me try to plot it on the real line to find the solution set. Okay, so we have here, we have -1 and we have 2 here, and we have here we have 1/2 here. So these are just the points. For the first case, we have this to be -1. Okay, -1 closed at -1 but open at 2. Okay, so here this is the for this condition here, and we now have this result here. We now have x to be less than, strictly less than what? 1/2. So we now have here open at this end. Okay, it goes in this direction, so we have this. So if I should ask you what is the intersection of these two graphs, obviously the intersection of these two graphs is what? Is closed at this end and open at this end. So the solution set for this case, therefore, can I write that the solution set for this case is what? Is let me just write it in interval form here. I will have this to be -1 closed at -1 here. Okay, so closed at -1 here, then comma 1/2, comma 1/2. Okay, good. So it's closed at this end here, open at this end here, because here it is open. So that's just, now what am I doing here? I'm trying to look at the intersection of these here, this condition here, and this condition here, that gives me this. Then for the case 3, so we want to look at when x is now bigger than 2. So if x is greater than 2, if x is greater or equals to 2, okay, so if x is now bigger than 2, so let me use a different color for that one. Let me use a yellow color. So if x is now greater than 2, obviously x is going to be greater than -1 also. So here this is the third condition, and here this is the third condition. So we want to look at these two conditions here, this and probably this. Yeah, so what will happen to the absolute value of x minus 2? That's if x is greater than 2. So that means I'm going to have this to be what, x minus 2 to be greater than what, x plus what, 1. Okay, so I have x minus 2 to be greater than x plus what, 1. And now if you look at this, of course I'm going to have this to be -2 to be greater than 1. -2 is greater than 1. That's absurd. This is absurd. This is not possible. So that means that what, there is no solution. So that means that the given equation has no solution in what, in this interval. So that means this equation has no solution in this what, in this, it has no solution in this interval. So no solution. So therefore no solution in this region in 2, infinity. Okay, in 2, so there's no solution in this what, no solution in this region. So now let's now consider the union of our two solutions. That is the solution we have here and the solution we also have here. So let's consider their union. So the solution set is given as what? So for the first case, we have this to be -infinity. So the solution set is given as the union of -infinity, -1, okay, union 1, 1/2. So what do you observe? You see that it is open at this end and it's also closed at this end. So that means we can actually match them together. Let's say, so that means we have this to be -infinity, 1/2. So -infinity, 1/2. So it is open at this end and it's also open at this end. So this is the solution set. So that means that what, I think, so if I should pick points, if I should pick a point negative, if I should pick a point 1/2 here, so the solution is actually in this region like this. It's actually in this region like this. So any region aside from this will not work. So I hope that is very clear. So any solution around this will not work. You can pick any value. Let's pick 3. Let's say we pick 0.3. Let's say we pick x to be 3. So if x is 3, that means we have 3 minus 2, which is what, 1. Are you telling me that 1 is greater than 4? Are you telling me that 1 is greater than 4? Are you kidding me? Obviously 1 is not greater than 4. That's totally absurd. So the solution will only work when my x is in this region. Now let's take, for example, let's say we pick x to be -3. Let's pick x to be -3. So here we are going to have -5. That's absolute value of -5. Of course, this is going to be 5. 5 is going to be greater than 4. That's true. Okay, so obviously that's true. Now let's try to see, let's see if we can use different methods to solve this. Okay, just for you to see how we can approach mathematics differently. You recall that the absolute value of a all square is still the same thing as what, a square. Okay, meaning that what, if I should square both sides, that is if I should square x minus 2 to be greater than absolute value of x plus what, 1. So meaning that if I should square both sides, which is allowed, okay, if I should square both sides, that means that what, I'm going to have what, x minus 2 all square from this property. Okay, the absolute value of a all square is still the same thing as squaring what is inside. Okay, as long as it's going to give you a positive answer. Obviously a square is going always positive. It's always positive. So if I should take the absolute value of a number, it's going to give me a positive answer. So if I should square it, it's going to give me a positive answer. So that means this is what? This is true. Now let's continue. So here we have x minus 2 to be x minus 2 all square to be greater than what? X plus 1 all square. So let me try to expand this here, which is just obviously simple mathematics, and this will take care of itself. That means I'm going to have this to be minus 6x. That's if I bring 2x to the other side, to be greater than minus 3. And if I should divide both sides by negative 6, divide both sides by negative 6. Obviously, anytime you are dividing by negative sign, your inequality shall reverse. So that means this is going to be what? 1 over 2. And if I should put this in interval form, I'm going to have this to be negative infinity, comma 1 over 2. Of course, we have the same results. Okay, so let's just move on to the next question. So here we are asked to solve this inequality. Okay, so I won't be tired of repeating my method 1 and method 2 because I want you guys to understand the concept behind partitioning of partitioning of your real line to solve inequality. It's actually like the best method for solving inequality as far as I'm concerned, and you will appreciate that in the last few questions on this solving of inequality. So let's just go ahead and solve this inequality. Again, I want to partition my solution into different intervals on the real line. Obviously, I'm only given just one absolute value. So if I should set the argument there to be 0, so if I should set 2 minus 5x to be equal to 0, that means that what? My x is going to be what? 2 over 5. Okay, so meaning that my real line is going to be divided into 2 parts. So let's say my point here is 2 over 5. So I will have the section where x is less than 2 over 5, and I will have this section where 2 over 5 is less or equals to x, or when x is greater or equals to 2 over 5. So, and now let's write our absolute value of 2 minus 5x out. Okay, so this is going to be 2 minus 5x. That's if 2 minus 5x is greater than 0. Can rewrite it as 2 minus 5x to be greater than 0. So if 2 minus 5x is greater than 0, that means that what? If I should solve this, that means I'm going to have minus 5x to be greater than minus 2. That means x is going to be less than 2 over 5. So that means here, this is true. That's if x is less than 2 over 5. Okay, so here I'm going to have negative of 2 minus 5x. That's if 2 minus 5x is what? Is less than, that's if 2 minus 5x is less than 0. Obviously, I'm going to have 5x to be less than negative 2. And that means I'm going to have x to be greater than what? 2 over 5. So here, I'm going to have this to be what? If x is greater than 2 over 5. Okay, so you can see how those things are changing. So you have to take note of that, and you can only take note of that if you actually solve more problems on what's on this inequality. So let's just continue now. So for the first case 1, so I want to consider the case where x is strictly less than 2 over 5. So if x is strictly less than 2 over 5, what will happen to the absolute value of 2 minus 5x? 2 minus 5x is going to be what? It's just going to be what? 2 minus 5x. It's not going to change. So which is going to be what? Less or equals to what? 7. And if I should solve for x here, if I should bring 2 here, that means I'm going to have 5x minus 5x to be less or equals to what? 5. Dividing both sides by negative 5, I'm going to have my x to be greater or equals to what? Negative 1. Again, you draw the solution set. So here I have negative 1, and here I have 2 over 5. From here I have x to be less than, strictly less than 2 over 5. So I'm in this region here. And for the second region, I have x to be greater or equals to 1. So I have this region here. So if you look at what is the intersection of this region, the intersection of this region, or the solution set for this case, is what? Solution set for this case is what? -1 closed at this end, comma 2 over 5, which is what? Open at this end here. So we are done with the first case. So for the second case, so for case 2, okay, so we want to consider the case where x is greater or equals to what? 2 over 5. So if x is greater or equals to 2 over 5, okay, that means that what? The absolute value of 2 minus 5x is going to be what? Negative of 2 minus 5x. Okay, that's if x is greater than 2 over 5. I've just discussed why this is greater. Okay, you have to be careful of these conditions here. You have to work them out for you to get the right condition, which I've done earlier. So here I'm going to have this to be negative of 2 minus 5x to be less or equals to what? 7. Now if I should expand, that means I'm going to have negative 2 plus 5x to be less or equals to what? 7. And if I should add 2 to both sides, that means I'm going to have 5x to be less or equals to 9 divided by 5 divided by 5. That means my x is going to be what? Less or equals to 9 over 5. And if I should look at the solution set for this case, I'll draw my real line. Then here I'll have this to be 2 over 5, and this is what? 9 over 5. Here we are given that x is less or equals to 9 over 5, so it's shaded at this end. So I have this here, and here I have x to be greater or equals to 2 over 5, so I have this shaded here, so going in this direction. So what is the intersection of these two graphs? The intersection of these two graphs, which is the solution set for this case, is what's closed at this end because of this 2 over 5 is closed here. That's 2 over 5 comma 9 over 5, so closed at this end. Again, since we consider two different cases, for us to now get the real solution for this set, we need to take the union of these two cases. So the union is going to be what? So the solution set is going to be what? The union of -1 comma 2 over 5 open at this end, union closed at this end, 2 over 5 comma 9 over 5 closed at this end. So which is going to give us what? -1 closed at this end comma 9 over 5, which is also closed at this end. Now let's look at the second method for solving this problem. Now don't forget that if you have the absolute value of a to be less or equals to b, this is true. This implies that negative b is less than a, which is also less than what? B. Okay, so meaning that what? I will have -7. So that means if the absolute value of 2 minus 5x less or equals to 7 implies that what? -7 is less than 2 minus 5x, which is less than what? 7. Okay, now let me try to even explain something further for you guys. This statement here means that what? This means that what? Negative b is less than a and a is less than b. Okay, negative b less than a, or let's say negative b straight less or equals to a, and a is less or equals to what? B. So what I'm saying in essence is that I can solve these two separately. Okay, so this implies that what? -7 is less than 2 minus 5x. There's less or equals to here. Let me forget it. And so I just use this symbol for wedge sign. And 2 minus 5x is less or equals to 7. So if I should solve this independently, okay, I will have, that is, if I should bring 2 to the other side, I'm going to have -7 to be -2 is less or equals to what? -5x. And I'm going to have what? -5x to be less or equals to 7 minus 2. So that implies that what? This implies that -9 is less or equals to -5x, and -5x is less or equals to what? 5. So if I should divide both sides by -5, -5 here, -5 here, -5. Don't forget that when you are dividing by negative sign, your inequality can be reversed. So that means I'm going to have this to be 9 over 5 to be greater or equals to what, x, and x to be less or equals to what, -1. Okay, so if 9/5 is greater or equals to x, this implies that what, x is what, less or equals to what, 9/5, and x is less or equals to what, -1. I can swap this. Actually, I can bring this to the other direction. That means I will have -1 to be greater or equals to what, x, and x is less or equals to 9/5. Okay, so which implies that what, -1, sorry, this should have been greater or equals to, because I was dividing by negative sign, so this should be greater or equals to. We are not computers, we also make some little errors, so pardon me for that. Okay, so this should now be less or equals to, so we have -1 is less or equals to what, x, and x is now less or equals to 9/5. So I've corrected my error. So that implies that what, I'm going to have this to be -1, 9/5. So by the time you combine this inequality, I'm going to have -1 to be less or equals to what, x, which is less or equals to what, 9/5. And we are done with this question. So let's move ahead to the next question. So in this question here, we are asked to find all values of x which satisfy this inequality. Okay, so again, I'm going to attempt this question rigorously, like trying to break it into interval. Now before I do that, you observe that what, in this question here we're having quadratic. Now you observe that what, the absolute value of a multiplied by the absolute value of b can be written as the absolute value of a, b. Okay, so here this can be written as what, this can be written as the absolute value of x plus 2 multiplied by the absolute value of what, x minus 2 to be less than what, to be strictly less than 5. That one is what, that one is true. Okay, so that means that what, we need to set these two arguments to be equal to 0. So if we should set x plus 2 to be equal to 0, and we set x minus 2 also to be equal to 0, that means that what, we are going to have x to be what, -2, and x to be what, 2. So that means on our real line, we can partition our real line into 3 different parts. So let's say we have this to be -2 and we have this to be 2. So the first part is when x is what, is strictly less than -2. The other part is when x is greater or equals to -2 but less than what, strictly less than 2. And the last part is when x is greater or equals to what, 2. Now let's now define our next thing is to define our absolute value of x. The absolute value of x plus 2 is going to what, is going to be x plus 2. That's if x is greater than -2, and it's going to be negative of x plus 2. That's if x is less than -2. And again, the absolute value of x minus 2 is going to be what, so here we are going to have this to be x minus 2. That's if x is greater than 2. And here we are going to have this to be negative of x minus 2. That's if x is less than 2. Okay, so let's now try to solve those cases one by one. So for the first case, we have, so for case 1, okay, so for case 1, that's if x is less than, strictly less than -2. So what will happen if x is less than -2? Definitely x is also going to be less than what, 2. Okay, and here what will happen to the absolute value of x plus 2? So let's just try to here we have x to be less than -2. So this is case 1, and this is also what, so here we also have this to be what, case 1. Okay, so meaning that what, this is going to be what, the absolute value of x plus 2 would be -x, okay, -2 multiplied by multiplied by negative x plus what? Plus 2. So if I should use negative to open this bracket, I'm going to have negative x plus 2. So which is what? Strictly less than 5. And if I should expand this bracket, I'm going to have what? I'm going to have this to be x squared then plus 4, minus 4 to be less than 5, which implies that what? X squared minus 9 is less than 0 if I should bring 5 to the other side, and which implies that what? X minus 3 multiplied by x plus what? 3 is going to be less than 0. So meaning that I'm going to have the solution set for this one is what? This is a quadratic graph, and if you should plot your quadratic equation, it will look like this, because the quotient of x squared is what? Is positive. So the graph is going to look like this, and it's going to cut it at 2 points. That's at point -3 and at point what? 3. Okay, and now because this is less than 0, you are looking at the values of x for which the graph is what? Less than 0. So the part of the graph that is less than 0 is just simply this part here. Okay, so if I should write it in interval form, so what would be the value of x? The value of x which makes this graph to be less than 0 is when x is strictly between what? So that means the solution set for this one is going to be what? -3 comma what? 3. Okay, so which implies that what? X must belong to this interval. Okay, so directly from here. Now we just solve this this quadratic inequality. Now we need to now take it with the intersection of this particular point also. Now if you should look at it, let's say this is -3 comma 3, and we have -2 somewhere here. Okay, so we have -2 somewhere here. Here we have this open at this point, so this is open here, and this is also open here. So we have this graph joining together, and again we now have what? From the first condition, we have x to be strictly less than -2, so we have x is strictly less than -2, so we have this interval here. So if you should look at the intersection of these graphs, where do they intersect? So they intersect at what? So the solution set is what? Therefore the solution set for this case is what? Solution set for this case is what? -3 comma -2. Okay, it's open at this end and it's also open at this end, because this is where they intersect each other. Now for the second case, that's for case 2. So I want to consider when x is strictly greater than, when x is greater or equals to -2 but strictly less than 2. So we are looking at this. So when 2 is less or equals to x less than 2. So what happens to, so if x is greater than, so I'm looking at this region here, so I'm considering this region here. So that's if x is greater than -2. So this is going to be second case, and here this is going to be the, so meaning that x is going to be less than 2 here. So this will be the second case also. So you can just number it so that it will be easier for you to pick. So what will happen to the absolute value of x plus 2? The absolute value of x plus 2 will remain as what? X plus 2. And why the absolute value of x minus 2 would be what? That's if x is less than 2. That means this is going to give us what? -x plus 2 to be less than what? To be strictly less than 5. And if I should open this bracket, I'm going to have this to be what? X squared minus 4 to be less than 5, which implies that what? So here I'm going to have negative of x squared to be less than 5, which implies that what, because here if I should open this bracket, I'm going to have negative of x squared minus negative of x squared plus 4, which is still the same thing as what, negative open bracket x squared minus 4. I hope we get the idea. So if I should divide both sides by negative, that means I'm going to have this to be x squared minus 4 to be greater than minus 5. So if we should try to solve this quadratically, this quadratic inequality, so that means we have this to be x squared plus 1 to be strictly greater than 0. And now you will notice that this quadratic equation will have no roots on the real axis. It will have no roots on the real axis because of the fact that this is a complex quadratic equation, okay, which is now greater than 0. It will have no roots on the real axis. So the solution set for this case, is just simply this interval here. That's just -2 closed at this end and open at this end here. Then for the third case, that's for case 3. So we want to consider, for case 3 we want to consider when x is greater or equals to 2. So we want to consider when x is greater or equals to 2. Obviously x will be greater than -2 and also x will be greater than 2. So if I should plug it directly into this, apply it here, so what am I going to have? That means the absolute value of x plus 2, if x is greater than 2, would be what? Would be x plus 2 directly from here. Okay, that's if x is greater than -2. So it will just be x plus 2 multiplied by, so if x is greater than 2, x minus 2 would be what? The absolute value of x minus 2 would just be what? X minus 2 to be less than 5. And if I should expand this, I'm going to have x squared minus 4 to be less than 5, which implies that what? X squared minus 9 is less than 0. And if I should solve this quadratic inequality, I'm going to have x belong to the set of -3, 3. Okay, so if I should combine if I should take the intersection of this graph here and this graph here, so that means I have -3 here and I have 3 here and I have 2 at this in between them. So here this is open at this end, this is also open at this end, and this is the region here, and here I have 2x greater than or equals to 2. So I will shade this point here and I will go in this direction. So that means that what the solution set for this case would be what? The solution set for this case would just be closed at this end, that's 2, 3, open at this end. So if I should take the union of the 3 conditions or the 3 cases, what am I going to have? So if I should take the union of the 3 cases, the solution set is going to give us what? That means the solution set would be what? Would be, so for the first case we have this to be -3, -2 union. For the second case, closed at -2, that's 2, 2. Then for the last one we had closed at 2 and open at 3. So if I should take the union of these 3 sets, what am I going to have? This is open here, this is closed here, this is open here, this is closed here. So what am I going to have? I'm going to have -3, 3, open at -3, and it's also open at 3. So, and the easiest way to do this is another way to do this is just to rewrite this as what? So we can write the absolute value of x squared minus 4 to be less than 5 as what? Negative 5 to be less than x squared minus 4, which is less than 5. And if I should add 4 to both sides, what am I going to have? I'm going to have this to be negative 5 plus 4, that's negative 1 to be less than x squared, and which is also strictly less than. If I should add 4 to this side, I'm going to have this to be 9, in which I can break this into two separate parts. So that means I'm going to have negative 1 to be less than, strictly less than x squared, and x squared to be less than what's 9. Okay, and here this will have no real value, so that means the solution to this is just the real line. Okay, to just contain all the, it will be true for all the real line. Okay, so the solution to this one is to this is what r. If you plug in any values of r, it will always be greater than negative 1. So the solution to this is just what r. You're now intersecting it with what? The solution to this set, so which is what? Which is obviously x squared minus 9 to be less than 0, and we've done this earlier. This is what? Negative 3 comma what? 3. So if I take r intersection this, the intersection of r and the interval, open interval 3 minus 3 and 3 would give us what? Negative 3 and what? 3. Okay, because if you take the intersection of a larger set and a smaller set, and since the smaller set is a subset of the larger set, the intersection will just be the smaller set, which is what? Negative 3 comma what? 3. So let's move ahead to the next question. In this question, we are asked to find all x in R which satisfy this inequality. Okay, again, for us to solve this inequality, we just need to partition the values of R, or the values of R on the what? On the real line. And if we should do that, we just need to do that by setting the argument here to be what? To be 0. Okay, so if we should set that to be 0, that means we have this to be what? 0, and x to be 0, and we also have x plus 2 also to be what? To be 0. And the absolute value of x itself is what? Is x if x is what? Greater than 0, and negative x if x is what? Is less than 0. And also the absolute value of x plus 2 is what? Is x plus 2, that's if x is greater than 0, and negative of x plus 2, that's if x is, sorry, this should be greater than negative 2. This should have been negative 2, so this should be greater than negative 2, and this should be less than this. So if x is less than negative 2, and here if we should partition our real line, so here we have this to be negative 2, and here we would have this to be 0. Okay, so we've partitioned our real line into 3 different intervals. So the first interval is what? The first interval is when we have x to be, strictly less than negative 2, and the second interval is when we have negative 2 to be less or equals to x and is strictly less than 0, and the third interval is when 0 is less or equals to what? X. Okay, so for the first case, or for the first interval, for case 1, so if x is less or equals to, sorry, if x is less than, is strictly less than negative 2. So if x is, for the first case, so we are considering the interval when x is strictly less than negative 2. So if x is strictly less than negative 2, so what happens? So that means that I'm going to have x, so here I'm looking at this region when x is less than negative 2, strictly less than negative 2. Obviously x will also be what? Less than 0. So this is for the first case, and this is also for the what? For the first case. Okay, so that means I'm going to have the absolute value of x to be negative x, and I'm also going to have the absolute value of x plus 2 to be negative of x, negative 2. which is what, less than 5. So that means that I'm going to have negative 2x to be less than, strictly less than 7. So which implies that what, x is greater than negative 7 over 2. So if I should plot this on the number line, so here I have this to be negative of 7 over 2 and I have this to be negative 2. So what do we notice? We notice that what, x is greater than 7 over 2 is this region, and when x is, so for this condition, when x is less than negative 2, so we have this condition here. So where do they intersect each other? So they intersect each other at what? So the solution set for this case, solution set for this case is what, is negative 7 over 2 comma negative 2, open at both end. So for the case 2, so for case 2, so we want to consider the region where x is now what, is now above negative 2 but below 0. Okay, so here we have negative 2 to be less or equals to x, strictly less than what, 0. Obviously x will be greater or equal, x will be greater than negative 2 and x will be less than 0. So here we have x to be greater than negative 2, which is this condition here, and here less than 0, so we are looking at this condition here. Okay, so here what will happen to the absolute value of x? The absolute value of x is still going to be what, negative x, and the absolute value of x plus 2 would be what, the absolute value of x plus 2 would be x plus 2, since x is greater than negative 2. Now we now have this result to be less than 5. Okay, so meaning that what, if I should solve this inequality, so here we have 2 to be less than 5, which is what, which is true. Okay, so the solution set for the, that means the solution set, okay, for this case is what, is just this interval here. So we have negative 2, closed at negative 2 and open at what, 0. Okay, so that's for case 2. Then for the last case, that's for case 3. So we want to consider when x is now, so when x is now greater than negative 2 and is also greater than 0. So that's when x is strictly greater or equals to 0. So obviously x will be greater than negative 2. So here look at the third condition here, and this is also the third condition here. So what will happen to the absolute value of x? The absolute value of x would be x, while the absolute value of x plus 2 also would be what, x plus 2 to be less than 5. So meaning that what, I'm going to have 2x to be less than 3. So that means my x is going to be less than 3 over 2. So I need to take it with the intersection of this interval. Okay, so on my number line I have 0 and I have 3 over 2. So here I have x to be greater or equals to 0. So meaning that here shaded here goes in this direction, and here and I have x to be strictly less than 3 over 2. So it's open at this end and going in this direction. So where do they intersect? So they intersect in the region. So the solution set for this case, the solution set for this case is what, is closed at this end but open at 3 over 2. Okay, so if I now take the union of case 1, case 2, case 3, so the solution set for the inequality, therefore the solution set would now be the union of case 1. So what's my case 1? My case 1 is negative 7 over 2 comma negative 2 union negative 2 comma 0 union close that this end 0 comma 3 over 2. So meaning that what the solution set is just going to be negative 7 over 2 comma 3 over 2. So this is our final answer. So let's go ahead to the last sub question for this question. Now we have to find all x in R which satisfy this inequality. Again, try to partition our answer on the real line. Okay, so that means that what we need to set each of these values here to be what, to be 0. Okay, so meaning that if we do that, what are we going to have? We set, so if we set x to be what, 0, we set x plus 2 to be what, 0, and we also set 2 minus x to be what, 0. That means that what we are going to have x to be what, 0, negative 2, and what, 2. Okay, so if we partition it on the real line, we are going to have negative 2, we are going to have 0, and we're also going to have what, 2. So that means we partition our real line into 4 different intervals. So the first interval is when we have x to be what, to be strictly less than negative 2. The other interval is when x is greater than negative 2, greater or equals to negative 2, but strictly less than 0. And we also have of the interval when x is what, is strictly greater than, is greater or equals to 0, but less than or strictly less than 2. And for the last interval, we have this to be, so we have when 2 is less or equals to what, is less or equals to x. By definition, what is the absolute value of x? The absolute value of x itself is what, is x. That's if x is what, is greater than 0, and negative x, that's if x is what, less than 0. And what of x plus 2? X plus 2 will be what, x plus 2, that's if x plus 2 is greater than 0, or you can write if x is greater than negative 2. And negative of x plus 2, that's if x is less than negative 2. Now what of the absolute value of 2 minus x? This is going to be what, 2 minus x, that's if 2 minus x is greater than 0, which is still the same thing as if 2 is greater than x, or you can write it as if x is less than 2. And it's going to be negative of 2 minus x, that's if x is greater than what, 2. Okay, now let me try to explain this part to you guys. The condition that's supposed to be here is what, that's if 2 minus x is greater than 0, and here that's if 2 minus x is less than 0. Here, if I should solve for x, I will find out that what, x is greater than negative x is what, is greater than negative 2. And here I will have negative x to be less than negative 2. If I should divide both sides by negative 1, I'm going to have x to be less than 2, and here I'm going to have x to be greater than 2. So that's why I have these two conditions to be kind of different. So you have to be careful of that particular part there. Okay, so let's move on. Now don't forget that I need to solve this in 4 different cases. So for the first case is when my x is strictly less than negative 2. So if my x is strictly less than negative 2, so what happens to absolute value of x? So if my x is strictly less than negative 2, definitely the absolute value of x would be what? Obviously x would be less than 0, and x would be less than negative 2, so I will just put first condition here, and x will also be less than 2, so this is also my first condition here. So I will just have this to be negative x. So if x is less than negative 2, the absolute value of x would be what? Would be negative x from here, then plus, so I just need to expand this. I don't need to rewrite this. So if I should expand this, I'm going to have this to be negative x negative 2. Okay, if I should expand this particular part here. So negative times x will give us negative x, then negative times plus 2 will give us negative 2, then plus. So if x is less than 2, that means I'm going to have this to be what? Plus 2 minus x to be less or equals to 8. And here I'm going to have negative 3x to be less or equals to what? To be less or equals to 2 will cancel this 2 here. Negative 2 plus 2 will give us 0. So this is less than or equals to 8. And if I should divide both sides by negative 3, that means that what? X is going to be greater or equals to negative 8 over 3. And if I should take it with the intersection of this interval here, so I have on my, so I have here to be 8 over 3, and I have here to be what? Negative 2. So this is going in this direction, shaded in this direction, and it's going in this direction. And why this is unshaded and it's going in this what direction? So what is it? Where does these two graphs intersect? The two graphs intersect at what? At, so we can now write that the solution set for this case, the solution set for this case is what? Is closed at this end, which is negative 8 over 3, and it's now open at this end, which is what? Negative 2. So we can open it at this end like that. And for case 2, so for the second case, so we are considering the interval negative 2 less or equals to x less than what? 0. So we are looking at this region here. So when x is greater than negative 2, so this is for the second condition. So for case 2, so when x is greater than negative 2, obviously x will be less than 0, so and x will be less than 2 also. Okay, so meaning that what? The absolute value of x would still remain as what? Negative x, because x is less than 0. Then here I will have this to be absolute value of x plus 2 would be x plus 2, because x is now bigger than negative 2. Then for the third one, I will have this to be what? 2 minus x to be less or equals to 8. And if I should solve this, negative will cancel out, then that means I will have this to be negative x to be less or equals to 8 minus 4 will give us 4. So that means that's what? My x is greater or equals to negative 4. So if I should take it with the intersection of these two regions, so let's try to draw the region. So here I have negative 2 and here I have 0, and I'm sure that negative 4 would be here. So here x is greater or equals to negative 4, so that means I'm looking at this what? Region here. And again I have the region where x is greater than negative 2 but less than 0, strictly less than 0, so we just have it to be open here. So if I should shade this interval, I have this. So where does these two graphs intersect? So these two graphs intersect each other at what? At somewhere open at negative 2, sorry, closed at negative 2 and open at 0. So the solution set for this case, the solution set for this case is what? Negative 2 comma 0. So open at this end, because 0 is open at this end. So let's move on to the third case. So for case 3, okay, so we want to consider the region where 0 is less or equals to x and strictly less than 2. Okay, so if x is greater or equals to 0 and strictly less than 2, so that means we are looking at this region here. Okay, so definitely x is greater than 0 and x is greater than negative 2, but x is strictly less than 2, so we still look at this third condition here. So that means the absolute value of x would be what? X, and the absolute value of x plus 2 will be what? X plus 2, and while the absolute value of 2 minus x would be what? 2 minus x, which is less or equals to what? 8. Okay, so here we have x to be less or equals to what? 4. Now if we should take it with the intersection of this region, so here we have the region where we have this to be 0 and 2, definitely 4 should be somewhere here. So x is less or equals to 4, so shaded here. Okay, so this region here, and here again we now have 0 to be strictly greater than x is strictly greater than 0, but here is open here, so we have this region here. So if I should ask you, where does these two graph intersect? So the intersect, so the solution set for this graph, for this case, is what? Is 0, closed at 0 but open at what? Open at 2. Then for the last case, that's for case 4, so I want to consider the region where x is greater or equals to 2. So where x is greater or equals to 2, or where 2 is less or equals to x. So if x is greater or equals to 2, definitely x must be greater than negative 2, and it also must be greater than 0. So this is for the fourth case, and this is for the fourth case, and also this is for the fourth case. Okay, so here we're going to have the absolute value of x to be what? X. The absolute value of x plus 2 would be what? X plus 2. While the absolute value of 2 minus x would be what? Minus 2 plus x. Okay, which is less or equals to what? 8. And now this implies that what I will have for 3x to be less or equals to what? 8, which implies that what? X must be less or equals to what? 8 over 3. And if I should put this on the number line, so here I have 2 here and I have 8 over 3 here. So here x is less or equals to 8 over 3, so I have this interval here. And on the other hand, I have x to be greater or equals to 2, so I have this interval here. So meaning that where do these two graphs intersect? So they intersect at what? At 2, closed at 2, and also closed at what? 8 over 3. Okay, so we have 4 cases. As usual, we take the union of case 1, case 2, case 3, and case 4 for us to find the solution of this what? Of this inequality. So if we should take the union of the cases, so the solution set is going to give us what? So let's write that with a white marker. Okay, so the solution set would be what? The union of case 1, case 2, case 3, and case 4. So if I should take the union of case 1, so case 1 is what? Closed at negative 8 over 3 but open at negative 2. Case 2 is what? Closed at negative 2, open at 0. Case 3 is what? Closed at 0, open at 2. And case 4 is what? Closed at 2, open at what? 8 over 3. Okay, closed at 8 over 3 also. Closed at 8 over 3 also. So meaning that the solution set for this graph is just going to be what? This is open here, this is closed here, this is open here, this is closed here, this is open here, this is closed here. That means the solution set is just going to be what? Negative 8 over 3, comma 8 over 3. So that is the solution set for this what? For this graph. So I think negative 8 over 3 is somewhere here, and 8 over 3 is somewhere here. So this is the solution to this to this graph here. So any value of x you pick outside this region will not work for this inequality. You can always test it by yourself. So let's move ahead to the next question. In this question, they said prove that for all a comma b in R, that the absolute value of A minus the absolute value of B is less or equals to the absolute value of A minus B. Okay, now you recall that for any real number, let's say x in R, this is actually true. That is, the negative of the absolute value of x is less or equals to x, which is less or equals to the absolute value of x. And also, if I pick y in R also, that the negative of the absolute value of y is less or equals to y, which is also less or equals to the absolute value of y. Now, if I call this first equation second inequality, so if I should add these two inequalities together, what am I going to have? I'm going to have on the left hand side here, I'm going to have negative of the absolute value of x plus the absolute value of y, okay, is less or equals to x plus y, which is less or equals to x, absolute value of x plus absolute value of y. Okay, so what do you notice? You remember that the absolute value of A less than B implies that negative of B is less than, let me just use A less or equals to B here, so that I'll be consistent with my inequality. So here, this can be written as negative of B less or equals to A less or equals to what? B. Okay, this can also be written in the other direction. So this is if and only if this. So we've done this in question 1. Now, meaning that this can still be written, that this inequality over here can still be written as what? Can be written as the absolute value of x plus y to be less or equals to what? Absolute value of x plus absolute value of y. And this is known as what? The triangular inequality. So I'm going to use the triangular inequality to actually prove this inequality over here. So and how do I do that? So here is the thing. So let me write the proof of this. So we write proof. Now you observe that A, since A is in R, can be written as what? A itself can be written as A minus B plus what? Plus B. Of course, this will cancel out. Okay, so if I should take the absolute value of both sides, that means that what? The absolute value of A is what? The absolute value of A minus B plus B. Okay, so this will give us absolute value of A minus B plus B. So I'm just trying to put absolute value to both sides. Now if I should employ the triangular inequality here, okay, so that means if my A minus B represents my x, so if A minus B represents my x and y represents my b, so that means I can write this as what? That means I can write this as what? This is actually less or equal. So if I should apply the triangular inequality, that means I can write this as absolute value of A minus B plus absolute value of B. So which is what? So I will have this to be, at this side here, I will have this to be absolute value of A. So and if I should subtract absolute value of B from both sides, so that means that I'm going to have absolute value of A minus absolute value of B to be less or equals to absolute value of A minus B. So let me call this 1. Okay, so again, B again, since B is in R, that means that what? B can be written as what? B minus A plus what? Plus A. Okay, that implies that what? The absolute value of B. So if I should take the absolute value of both sides, that means the absolute value of B is what? The absolute value of B minus A plus what? A. Again, if I employ the triangular inequality again over here, so that means that what? I can write this as what? This is actually less or equals to the absolute value of B minus A plus what? The absolute value of what? A. So if I should subtract absolute value of A from both sides, that means that what? I will have this to be absolute value of B minus absolute value of A to be less or equals to the absolute value of B minus A. This implies that negative of the absolute value of B minus A is actually less or equals to absolute value of A minus absolute value of b. So this, if I bring this to the side and if I bring this term here to the side, so this the sign in front of them will change, still retaining the equality sign here. So let's call this 2. Now if I try to combine 1 and 2 together, that means that what I can write both of them together as what, from the second equation. Let me begin with the second inequality here. That means I will have negative of what, the absolute value of b minus a to be less or equals to the absolute value of a minus absolute value of b. Okay, now let me now continue with this first equation. From this first equation here, we have the absolute value of a minus the absolute value of b to be less or equals to the absolute value of a minus b. So that means I will have this to be less or equals to the absolute value of a minus b. Okay, and another thing is that you know that the absolute value of b minus a is still the same thing as the absolute value of a minus b. Okay, so that means that what, that means I will have this to be what, negative of the absolute value of a minus b to be less or equals to the absolute value of a minus absolute value of b, which is less or equals to the absolute value of a minus b. So from this axiom over here, from this axiom, that is, if you have negative of b less or equals to a less or equals to b, that means we can rewrite it as what, absolute value of a less or equals to b. So if you should observe clearly, that means that we can rewrite this as what, okay, so let's say this is representing our b and this is representing, all this term here is representing our a, so definitely this is going to be our b. So that means we can write this as the absolute value of what is at the middle here, which is absolute value of a minus absolute value of b, is less or equals to my b, which is what, absolute value of a minus b. Quite easily done. So we are done with the proof. So I hope you understand this particular proof. So let's just go ahead to the next question. In this question, they said that prove that if b is different from 0, that is, if b is not equal to 0, then the absolute value of a over b is equals to the absolute value of a all divided by the absolute value of b. Okay, so I'm going to prove this inequality with 2 different methods. So you can see method 1 and method 2 over here. So let's start with our first method. Now here they said if b is not equal to 0. So if b is not equal to 0, what does that imply? That implies that what is that we have b to be greater than 0, or we should have b to be less than 0. You can remember that if I give you any real number, okay, it's either the number is greater than 0, or the number is less than 0, or the number is what, equals to what, 0. But here the number is not equal to 0. That means that what, we have only 2 cases left. It's either the number is positive or the number is what, negative. Okay, now so here we can break this into 4 different cases. So the first case is when your a, so if a is positive, okay, so we are going to take it with when b is also what, positive. So because if a is in R, okay, that means that a is greater than 0 or a is less than 0. Of course, if a is equal to 0, it will be of a trivial case, so we may not pick that, because we are going to have, if a is equal to 0, we are just going to have 0 to be equal to 0, which is trivial. Okay, so we want to take the case when a is positive and b also is also positive. So if a is positive, what does that mean? That means that what, a divided by b is going to be positive, which implies that what, if a divided by b is positive, that means the absolute value of a over b is going to be what, a over what, over b. Okay, and if a is positive, that means that what, the absolute value of a is going to be what, a, and the absolute value of b also is going to be what, b. So that means this is what, this is true. So in the second case, that's case 2. So we want to consider the case where, so if my a is negative, let's say my a is negative and my b is positive, definitely if a is negative and b is positive, definitely a over b is going to be what, is going to be negative. That implies that what, the absolute value of a over b is going to be what, negative of A over B. What I'm just using here is I'm just using the definition of the absolute value of x. Don't forget that the absolute value of x is what is x if x is what is positive, and negative x if x is what negative. Okay, so that's the definition I'm using here. So if a over b is negative, definitely the absolute value of a over b is going to be negative of a over b. Got it? So again, what will now happen to the absolute value of a over absolute value of b? Absolute value of a, because a is negative, will be negative a, and because b is positive, will just be b. So in which I can write as what negative of a over b. So which is what still correct. So for case 3, that's if a is positive and b is what negative, and b is negative. So if a is positive and b is negative, definitely a over b is going to be negative, since one of them is negative. So if I should take the ratio, it's still going to be negative. So that implies that what the absolute value of a over b is going to be negative of what a over b, since a over b is negative. So what will now happen to absolute value of a over absolute value of b? Since a is positive, I'm going to have a positive a, and since b is negative, I'm going to have a negative b. Okay, from the definition of the absolute value of x. Okay, so which I can still write as negative of a over what over b, still the same result. Then for the fourth case, that's for case 4. So I'll consider when if a is negative and what b is also what is also negative. Okay, so if a is negative and b is also negative, definitely a over b is going to be positive, which implies that what the absolute value of a over b is going to be what a over b. And what will now happen to absolute value of a over absolute value of b? Since a is negative, absolute value of a is going to be negative a, and since b is also negative, absolute value of b is going to be what negative b. Definitely this is going to give us a over b. So you can see that this is also what this is also true. So in all those cases, we have the same, all the cases are actually true. Definitely this is going to be what this is going to be true. So another way to think about this actually is that since you know that the absolute value of x is still the same thing as what, so if I should square the absolute value of x, I'm going to have what x squared. So meaning that absolute value of x is still the same thing as square root of what of x squared. So this is the same thing as what square root of x squared. So if I should take the square root of both sides, I'm going to have this result. So meaning that the absolute value of a over b is still the same thing as what the square root of a over b all square, right? From this it just follows directly from this, and we can write this as what the square root of a square over b square using your law of indices, right? So which is still the same thing as, I can actually separate the radical sign, so I can have this to be square root of a square over square root of b square. Got it? Good. So which can still be written as what the absolute value of a over the absolute value of what b. And you know that for me to separate this radical sign, definitely b must not be equal to 0. So that means we're done. So this is true if b is not what equals to 0, and we are at what we are done with our proof. So can just write the proof is complete. So another way of writing it is what quite easily done. So let's move on to the next question. In this question, it said that show that for all a comma b in R, the absolute value of a minus b is greater or equals to the absolute value of a minus the absolute value of b. So here it gave us an hint that we should write a as open bracket a minus b plus b. So here, if we write a to be equals to a minus b plus b, if we take the absolute value of both sides, that means we are going to have the absolute value of a to be equals to the absolute value of a minus b plus what b. And we can apply our triangular inequality directly don't forget that if you have two real number, the absolute value of x plus y is less or equals to the absolute value of x plus the absolute value of y. Of course, you can think of triangular inequality as something like this. So let's say this is side x and this is side y, and let's say this is side x plus y. Okay, the magnitude of x plus the magnitude of y is far greater than the magnitude of x plus y, which is obviously true. That is, the addition of two sides of any triangle is always greater than the third side. That's just like your triangular inequality. So if I should apply the triangular inequality here, this will be less or equals to the absolute value of a minus b plus the absolute value of b. Don't forget that we have the absolute value of a here. And if I should bring the absolute value of b to the other side, that means I'm going to have the absolute value of a minus the absolute value of b to be less or equals to the absolute value of a minus b. And if I should, of course, if 1 is less than 2, that means that what 2 is greater than 1. So that means that the absolute value of a minus b is greater or equals to the absolute value of a minus the absolute value of b. So again, the proof is complete. So let's move ahead to the next question. In this question, we are asked to prove that for all a, b, and c in R, that the absolute value of a plus b plus c is actually greater than the absolute value of a minus the absolute value of b minus the absolute value of c. Okay, so I want you guys to take time to think about this problem. I want you guys to just take time to try and solve it yourself first before you come back to see the solution. Okay, all right, so I assume that you've done that, so let's just go ahead to the solution. Now the trick here is that since a is in R, that means that what I can write a to be equals to what a plus b plus c, right, minus b minus c. I think you can all agree with me, in which I can write as what I can write as a plus b plus c plus minus b then plus minus c. So meaning that what if I should take the absolute value of both sides, so that means that if I should take the absolute value of both sides, that means I'm going to have this to be the absolute value of a plus b plus c plus negative b plus negative c. So I can close the absolute value here. And now you remember your triangular inequality, that if I should have the absolute value of x plus y, of course I've been talking about triangular inequality since morning, so it's actually a major part in proving inequalities like this. So the absolute value of x plus y is actually less or equals to the absolute value of x plus the absolute value of y. That means that what if I call everything here my x and I call everything here my y, so that means that the absolute value of a would be less or equals to the absolute value of a plus b plus c plus the absolute value of negative of b plus what plus c. Okay, so of course this is going to give us, don't forget that the absolute value of negative 3 is still the same thing as the absolute value of 3. Okay, so that means that this is going to give us the absolute value of a plus b plus c plus the absolute value of b plus c. Okay, so and now if I should apply the triangular inequality to this to absolute value of b plus c, so that means that I'm going to have the absolute value of a to be less or equals to the absolute value of a plus b plus c plus, if I should apply triangular inequality to absolute value of b plus c, and that means I'm going to have absolute value of b plus absolute value of c. Okay, so if I should now take this b plus c to the other side, that means I'm going to have absolute value of a plus or minus absolute value of b minus absolute value of c to be less or equals to the absolute value of a plus b plus c. So which implies that what, of course, if 3 is less than 4, definitely 4 will be greater than 3. That means that the absolute value of a plus b plus c is obviously greater or equals to the absolute value of a minus absolute value of b minus absolute value of c. So this means that the proof is complete. So let's move ahead to the next question. In this question, it says show that for a comma b in R, ab is less or equals to 1 over 2 open brackets a square plus b square close brackets. Now since a and b belongs to R, you recall from the field property of R, which says that if I have b in R, there must also exist negative b in what? In R. Okay, so since I have a in R, since a belongs to R, that means that what a plus minus b must also what belongs to what R. That's the closure property of what? Of real number. And also you remember that for any real number, okay, if I should square it, it's always what? It's always positive. The square of any real number is always what? It's always positive. Okay, having known that, let's now try to construct the proof. Now since a and b belongs to R, that means that what a minus b must also what belongs to what R. And also if I should square minus b, that means a minus b all square must always be greater or equals to what? 0. So if I should expand this, that means I'm going to have a square minus 2ab plus what? B square is greater or equals to 0. And if I should add 2ab to both sides, that means I'm going to have a square plus b square to be greater or equals to 2ab. Dividing both sides by 2, that means I'm going to have 1 over 2 open brackets a square plus b square is greater or equals to what? ab, which implies that I can write it as what? ab to be less or equals to 1 over 2 open brackets a square plus b square. So we are done with the first proof. Again, since for the second one we are asked to prove that 1 over 2 open brackets a plus b all square is less or equals to a square plus b square. Now since a and b belongs to R, okay, that implies that what? A square plus what? B square minus 2ab. Alright, so directly from here. Now for the second question, we are asked to show that 1 over 2 open bracket a plus b all square is less or equals to open bracket a square plus b square. Now since a and b belongs to R, definitely a minus b must also belong to what? R, which implies that what? A minus b all square must be greater or equals to 0. And this implies that what? If I should square this, that means I'm going to have a square plus b square minus 2ab to be greater or equals to 0. So if I should adding a square plus what? B square to both sides, that means I'm going to have what? I'm going to have a square plus b square minus 2ab plus what? A square plus b square to be greater or equals to what? A square plus what? B square. That means that I'm going to have 2 open brackets a square plus b square to be greater or equals to what? A square plus what? B square. Then it is if I bring this to the other side, that means I'm going to have plus 2ab. So that means I'm going to have this to be what? 2 open brackets a square plus b square to be greater or equals to of course this can still be written as what, a plus b all square, and dividing both sides by 2, that means I'm going to have what, a square plus b square to be greater or equals to 1 over 2 open bracket a plus b all square, and which I can write as what, 1 over 2 a plus b all square, which is less or equals to a square plus b square. Now one thing that I want to mention here is the fact that the equality we hold here when x is equals to what, 0. Okay, so equality holds when x equals to 0. So if x equals 0, I'm going to have 0 to be equals to what, 0. Now equality will hold here when a equals to what, when a is equals to b. Okay, so if a equals to b, that means we are going to have a times a, which is a square, is going to be equals to 1 over 2 open brackets a square plus what, a square. So here I have a square to be equals to what, 1 over 2 a square plus a square is what, 2a square. So that means I'm going to have a square to be equals to a square. You can see that equality holds when a equals to b. It's also true for this one if a equals to b. So if you put a to be equals to b, that means I'm going to have 1 over 2 open bracket a plus a, which is what, 2a all square. You will see that it will be equals to 2a square. Okay, because if you should square this, I'm going to have 4a square divided by 2. 4a square divided by 2 will give me what, 2a square. That means I have 2a square to be equals to 2a square. You can see that equality holds when a equals to b. So let's move ahead to the next question. In this question, we have to show that for a and b in a real, the square root of ab is less or equals to 1 over 2 open bracket a plus b. Okay, taking a and b to be positive. Alright, so I'm going to do this using 2 different methods. Okay, the first one is kind of easier. You'll recall that we've actually proved that ab is actually less or equals to 1 over 2 open bracket a square plus what, b square. So if I take my a to be equals to square root of a, and I take my b to be equals to square root of b, if I should substitute it directly here, what am I going to have? I'm going to have what, square root of a multiplied by square root of b to be less or equals to 1 over 2 open bracket square root of a all square plus square root of b all square. So that means that I'm going to have square root of ab to be less or equals to 1 over 2 open brackets a square plus what, okay, this will actually cancel out. So that means I'm going to have a plus what, plus b. So we are done with this proof. So we have this result. Now again, since a and b belongs to R, that means that what, that means that a minus b all square must be what, must be positive, since a minus b belongs to R. So if I should take the square, it must always be greater or equals to 0. So if I should square this, that means that I'm going to have what, a square minus 2ab plus b square to be greater or equals to 0, which implies that what, a square plus b square is greater or equals to what, 2ab. So if I should add 2ab to both sides, so adding 2ab to both sides, so what will I have? I'm going to have, that means that I'm going to have this to be a square plus b square plus 2ab to be greater or equals to 2ab then plus 2ab plus 2ab. Okay, so if I should add this together, what am I going to have? That means that I'm going to have this to be a plus b all square to be greater or equals to 4ab. Okay, so if I should take the square root of both sides, that means that I'm going to have a plus b to be greater or equals to square root of 4ab. So that means that I'm going to have a plus b to be greater or equals to 2 square root of a b. Dividing both sides by 2, so that means that I'm going to have this to be a plus b over 2 to be greater or equals to square root of ab, in which I can write as what square root of ab to be less or equals to a plus b over 2. So this is actually known as the arithmetic. This is known as AMGM inequality. So we call this AMGM inequality, or we can call it GM AM inequality. So if I should write it in this form, so if a plus b over 2 is greater or equals to square root of ab, so we call this AMGM inequality. Okay, another way to write it is a plus b is always greater than 2 times square root of ab. Okay, so don't forget this. A plus b is always greater than square root of 2 plus what ab. Okay, and you can see that equality will hold when a is equals to b. So equality holds when a equals to b. Equality holds when what? When a equals to b. Got it? Yeah, because if a is equals to b, that means I'm going to have this side to be equals to what? 2a. And this side, if a is equals to b, I'm going to have this to be square root of a square, which is what? 2a. So you can see that they are equal. In fact, it also holds when a is equals to b is equals to 0. Of course, if all of them are 0, that means it's of a trivial case. That means I'm going to have 0 to be equals to 0, which is a trivial case. So I hope you get the idea. So if you like this video, make sure you click on the subscribe button and also on the notification bell. So let's move ahead to the next question. In this question, we have to show that for all a, b, c, d in R, with a, b, c, d being positive, the square root of ab multiplied by the square root of cd is less or equals to 1 over 4 open bracket a square plus b square plus c square plus d square. Okay, now again, you observe that since a and b is in R, definitely a minus b all square must be greater or equals to 0. So that means that if I should expand this, that means I'm going to have a square plus b square plus to be greater or equals to what? To be greater or equals to 2ab. So let's call this 1. Also, you also observe that c minus d all square will also be greater or equals to 0. And if I expand this, that means I'm going to have c square plus d square to be greater or equals to what? 2cd. So let's call this 2. So if I should add 1 and 2, so what am I going to have? That means that I'm going to have what? A square plus what? B square plus c square plus d square. Okay, this is actually greater or equals to 2ab plus 2cd. Okay, now what do you observe? You observe that from your AMGM inequality, okay, that's this. If you have the addition of two numbers, the addition of two numbers will always be greater or equals to 2 times the square root of the product. Okay, so from your AMGM inequality, you'll see that if I should apply the AMGM inequality to this guy over here, so what do you observe? So let's say this is my x and let's say this is my y. Okay, so that means that what I'm going to have a square plus b square plus c square plus d square to be greater or equals to 2ab plus 2cd. So if I should apply AMGM inequality, that means this is going to be greater or equals to 2 multiplied by square root of 2ab multiplied by what? 2cd. Okay, so which implies that what? A square plus b square plus c square plus d square is actually greater or equals to 2 times 2 will give us 4, so square root of 4 will give us 2, so 2 times 2 will give us 4 here again. So that means we have this to be 4 square root of a multiplied by b multiplied by C multiplied by D. And that means that's what I can write this as square root of AB multiplied by square root of CD multiplied by 4 is less or equals to A square plus B square plus C square and plus D square, which implies that what square root of AB multiplied by square root of CD is actually less or equals to 1 over 4 open brackets A square plus B square plus C square plus D square. And don't forget that equality holds when A equals to B equals to C equals to D, and it's also equals to 0. So equality holds when A equals to B equals to C equals to D. So if you equate A, B, C, D to each other, you see that you are going to have an equal sign here. So that's the meaning of equality holds when this condition what holds. Now we are done with that proof. So for the second one, we are asked to show that A multiplied by B multiplied by C multiplied by D, everything raised to power 1 over 4 is actually less or equals to 1 over 4 open bracket A plus B plus C plus D. Now the easiest way to go about this is to make A to be equals to square root of A, make B to be equals to square root of B, make C to be equals to square root of C, and make D to be equals to square root of D. So what do you observe? So if I should plug all these values in directly into this inequality, what will I have? I'm going to have A raised to the power of 1 over 2, okay, multiplied by B raised to the power of 1 over 2, multiplied by C raised to the power of 1 over 2, multiplied by D raised to the power of 1 over 2. Everything all raised to the power of 1 over 2 will be less or equals to what? 1 over 4 open brackets A raised to the power of 1 over 2 times what? Times 2, or raised to power 2, then plus B raised to the power 1 over 2 all square plus C raised to the power of 1 over 2 all square, then plus D raised to the power of 1 over 2 all square. So that implies that what I'm going to have A multiplied by B multiplied by C multiplied by D. Of course, this is everything is raised to the power of 1 over 2. That means I'm going to have 1 over 2 times 1 over 2, which is less or equals to 1 over 2. Sorry, this is 1 over 4 open brackets A plus B plus C plus D, because this will cancel out to cancel each other like this. Got it? So that means that I'm going to have A, B, C, D raised to the power of 1 over 4 to be less or equals to 1 over 4 open brackets A plus B plus C plus D. So, and we are done with the proof. So let's just go ahead to the last few questions. That's question 9. Here we are asked to solve the inequality. Okay, so I'm just going to do it with the easy method. Okay, so you recall that if you should have the absolute value of A to be greater than B, this implies that what is that A is greater than B, or look at the word or here, A is less than the negative of B. Okay, so that means if I should have the absolute value of x minus 1 over 2 to be greater than 1, this implies that what x minus 1 over 2 is that x minus 1 over 2 is greater than 1, or x minus 1 over 2 is less than the negative of 1. So which implies that what if I should solve this independently, that means I'm going to have x to be greater than 1 plus 1 over 2, or I should have x to be less than negative 1 plus 1 over 2. So which implies that what is that I have x to be greater than 3 over 2, or x to be less than negative 1 over 2. And if I should put this on a number line, I will have negative 1 over 2 here, and I will have 3 over 2 here. So if x is less than negative 1 over 2, that means I'm going in this direction. And if x should be less than 3 over, if x is greater than 3 over 2, that means I'm going in this direction here. So what is the union of these two sets? So the union is just simply, of course, this is going to be a disjoint union. because there's no common point between them. So that means I'm going to have negative infinity comma negative 1 over 2 open at this end union 3 over 2 comma infinity. And the last question for this tutorial series is this, or for the problem solving series is this. We have to solve the inequality, the absolute value of 3x minus 8 to be less than 0.1. Again, you recall that if you have the absolute value of a to be less than b, this implies that the negative of b is less than a and is also less than b. Okay, so that means that the absolute value of 3x minus 8 is less than 0.1. It implies that, or this is true if and only if negative of 0.1 is less than 3x minus 8, which is also less than 0.1. Don't forget that you can break this inequality into two. That is, you can have 0.1 to be less than 3x minus 8, and you notice the word and here, and 3x minus 8 to be less than 0.1. So this implies that what if I should add 8 to both sides? That means I'm going to have minus 0.1 plus 8 to be less than, strictly less than 3x, and 3x is strictly less than 0.1 plus 8. So this implies that this one here we have 7.9 to be less than, strictly less than 3x, and I'm going to have 3x to be less than 8.1. So if I divide both sides by 3, that means that it's going to be true if and only if 7.9 over 3 is less than x, and x is less than 2.7. And if I should put this guy on the number line, so here I will have 7.9 over 3, and here I would have 2.7. So here we have 7.9 is less than x, so that means I'm going in this direction. And here we have x to be less than 2.7, that means we are going in this direction. So what is the intersection of, where do these two graphs intersect? So the intersect are these common points here. So they intersect here and they also intersect here. So that means that the solution set for this inequality is simply open at 7.9 over 3 and it's also open at 2.7. Alright, so we are done with this question. So thank you very much for taking your time to watch this tutorial section. I hope you gain a lot from this video. I hope you are inspired to solve more problems, and if you like this video, make sure you click on the subscribe button if you have not done that, and don't forget to press on the notification icon so that you'll be notified whenever I upload a new video in this series. Now, what should you expect in the next video? What should you expect? You should expect the next exercise immediately after this video. Alright, again, thank you very much. I do really appreciate your love and support. I do really appreciate your comments in the comment section box below. Don't forget to give this video a thumbs up. See you next time.